now is very important. We can have this for a compressor or a transformer or a turbine turbine. These are actually true for all rotodynamic machines. We will define three things. First is head coefficient. First is known as uh, flow coefficient. Flow coefficient phi is Vx by u, where Vx is the velocity along the axis of the shaft, and u is the blade velocity. Blade velocity. Okay. Now head coefficient psi is equals to h0. First we will do this for a compressor. h0 2 minus h01 by u square. If I draw the HS diagram for a compressor, it looks something like this, where this is P1, this is P2, this is 1, this is 2, and this is 2, this is 2s, the isentropic process. This can be termed as T02, and this can be termed as 01. So for compressors, the head coefficient is this, and we have degree of reaction, which is H. The enthalpy difference, let me write it. Enthalpy difference in the rotor, enthalpy change divided by total enthalpy change. This H2 minus H1 divided by H3 minus H1. If I draw the stages of, this is the stator, sorry, this is the rotor, this is the stator, this is rotor, this is stator. If I draw the velocity triangle at the rotor starting, it will be, this is the rotor rotates in this direction. So okay, so this is u, so this is u, this is v1, this is u1. The exit velocity triangle will look something like this. It's w1, sorry, v2, w2, u, and this is the stator blades. So the rotor blades looks something like this. The stator blades look something of this sort, V3. And for repeating stages, V1 is equals to V3. So if we draw the two velocity triangles together, it will look something like this. This is one triangle where this is U, V1, W1. This is the second triangle, W2. So this is V2, this is W2. This is beta 2, this is alpha 2, and over here this is alpha 2, this is beta 2, sorry, this is alpha 1, beta 1, alpha 1, this is beta 1, right? So if we draw the, if we try to find out the degree of reaction, we have H2 minus H1, this is R divided by H3 minus H1. A very important property for rotodynamic machines, where U1 equals to U2 equals to U, and axial flow machines. We have relative stagnation enthalpy, which is known as H0R. So H0R1 is equals to H0R2. Okay, and how is this? We know that H01 equals to H01, H02 minus H01 is equals to VU2U minus VU1 into U, right? If from this triangle we get W1 square equals to U1 square plus V1 square minus 2 U1 V1 cos alpha 1, and this V1 cos alpha 1 can be written as VU1. So W1 square equals to U1 square plus V1 square minus twice U1 VU2. So U1 VU1. So U1 VU1 is given by U1 square plus V1 square minus W1 square by 2. Similarly, U2 VU2 is given by U2 square plus V2 square minus W2 square divided by 2, right? So if we replace these two with this and this, we have U2 square plus V2 square minus W2 square divided by 2 minus U1 square plus V1 square minus W1 square divided by 2. Since U1 equals to U2 equals to U, so these and these cancels out, right? And H02 is equals to H2 plus V2 square by 2, and H01 equals to H1 plus V1 square by 2. So we have, so if we substitute this over here, we have H2 plus V2 square by 2 minus H1 minus V1 square by 2 is equals to this whole thing. If we see that V2 and this V2 cancels out, and minus V1 and this is minus V1, this also cancels out. So we have W2 square minus W2 square by 2 plus W1 square by 2. If we see that H2, if we bring this over here and we take this H over here, we have plus W2 square by 2 equals to H1 plus W1 square by 2. So this is the relative velocity, and this term will be H0R, which is the relative stagnation enthalpy. This is constant for a rotor, for the input and output of a rotor. Okay, so if we use this property over here, so we have H2 minus H1 equals to W1 square by 2 minus W2 square by 2, and from this velocity triangle we have this this as WU2, and this one as WU1. So, and this is v this is vx. So yes, this is vx and vx are same. So we have w1 square equals to wu2 square plus vx square. This is w1, this is w1, this is wu2, this is vx, right? Similarly, v2 square equals to wu2 square plus vx square. So if we want to find out w1 square by 2 minus w2 square by 2, this will be w1 square wu1 square minus wu2 square divided by 2. These two cancels out. Okay, so if we add this will come. So I can replace this term h2 minus h1 equals to wu1 square minus wu2 square divided by 2. So this was the original equation for degree of reaction. This is degree of reaction. This was h1 h2 minus h1 divided by h3 minus h1. h3 is equals to h03 minus v3 square by 2, and h1 equals to h01 minus v1 square by 2. Also, as I have told, for repeating stages v3 equals to v1. So if we substitute this, we will have the denominator as h03 minus h01. Okay, sorry, and since there is no work that is done or that is developed in the stator, h03 equals to h02, so this can be changed as h02, right? And h02 minus h01 is vu2 vu2 minus vu1 into u. We can write this as we can using the same relations, right? We can not the same relations. We can write vu2. This is vu2. Let me change the color. This is vu2. So vu2. This is u minus wu2. Sorry, wu1. This is vu1. vu1 is u minus wu1. So vu2 is u minus wu2 and vu1 equals to u minus wu1. If we substitute this, we have u minus wu2 minus u minus wu1. This and this will cancel out. This is u, which is wu1 minus wu2 into u, right? So if we substitute this and this in this equation, we have r equals to wu1 square minus wu2 square divided by 2 into wu1 minus wu2 divided by u. So a plus a square minus b square, a plus b, a minus b is in the denominator, so this and only a plus b remains. wu1 plus wu2 divided by u into divided by 2. So this will be vx by u 1 by 2 wu1 plus wu2 multiplying and dividing by vx. So this is half. Vx by u is 5, and this is wu1 by u. So wu1, this is wu1, this is wu1, and this is vx. So cot beta 1, this is beta 1. So cot beta 1 is equals to wu1 by vx, and cot beta 2 is equals to wu2 by vx. So this is cot beta 1 plus cot beta 2. This is r. Okay, r can also be written as r is equals to from here itself. So r was wu2 you can write from here. So this is wu1 plus wu2 1 by 2 by u. So wu1 is u minus vu1. So we can write this as r equals to half into u minus vu1 plus wu2 divided by u. So this can be written as half into 1 minus now we can write vx by u and vu1 by vx plus wu2 by vx. Okay, this half minus this is 5 by 2, and this vx just a minus over here. So if we see vu1 by vx from the, so this is vu1 by vx, this is alpha 1, this is cot alpha 1 is equals to vu1 by vx. So we can write this cot alpha 1 minus cot beta 2. We have already seen how it is beta 2. Again, if we write r equals to half into wu1 plus u minus v u2 divided by u, this is half 1 plus, or we can write minus vu2 vx by u by vx minus wu1 by vx, right? So this will be half 5 by 2, this is cot alpha 2 minus cot beta 1, right? So when r equals to 0.5, from this equation we get cot, so this becomes half equals to half minus 5 by 2 cot alpha 1 minus cot beta 2. So this has to be 0 because this and this cancels out. So alpha 1 equals to beta 2, and from this equation we have alpha 2 equals to beta 1. So if we draw the triangles, the triangles will be mirror images to each other. So this is v1, okay, this is v2, this is w1, this is w2, so this is beta 2. Beta 2 is same as alpha 1, this is alpha 1, this is alpha 2, this is beta 2, sorry, this is beta 1, this is because this is w1, beta 1, right?